So if we go ahead and look at the code, you'll see that once again we'll get some standard testing data that's already present in the tools that we'll be using. In this case, the Keras tool. So we'll be using that MNIST data, MNIST data. We're going to plot that data sets, and then we will then, of course, train the data. So that means we'll get a subset of that data set, reshape that data set to make it comparable. So to fit the given model that we'll be using. So we give it a kernel size and as well as filter sizes that we apply to the training and then application of the data. So once we've categorized the data, we what's called one-hot encoding, a kind of categorization of the data so that it can be used to train and compare to the model that we'll be applying. So that then data is trained and then we'll apply a kind of sequence to the model. So you want to, of course, tell a CNN. So artificial neural networks effectively work like neural nets in your human mind and vision. So think of your eye. When you look at something, you see a shape. Only part of your neural nets will be activated at a given time, and that will respond and fire those neurons to signal to your brain that you're seeing something. So effectively, we're doing the same thing, but in a computational sense. And with neural nets, you want to tell how the networks will propagate and advance from one layer to a next effectively. And in our case, we'll be using a sequential advancement propagation, I guess. In this case, the model will be sequential. So we add that as the key component of how we advance the layers. So we'll be applying the convolutional layers as a first set, and then going to another one again. We'll flatten the image, which is basically putting the image back together using these activation layers that we talked about, that activation transformations, and then it'll allow us to then effectively recreate the image using a density function. And then we'll compile the model using accuracy as a measure of the model's performance, which will allow us to tell how accurate the model performed, and then we'll train the model and then show the predictive values. So that'll look at, for instance, how well the prediction is applied relative to the training that was applied earlier, and then show the results of that in line 60. So you can see in relatively few lines of code we can get a fairly sophisticated CNN model with multiple layers that compares the output to given empirical data sets. And so because this takes a while, I actually ran it in advance. You may actually need to run this several times. So if I run this, for instance, you will see it'll take a while before it gets to the end. And so I'm going to go ahead and let it run, and I'm going to stop the video to explain further.